Hi. In today's video lecture, we will go through electromeric effect. In previous video lecture, we have studied inductive effect, right? And these effects will activate the organic molecules, right? Since all these effects will help us to understand the mechanism of organic reactions. So basically, what we are studying in these effects, that how an organic molecule gets activated, because as we know that an organic molecule is a neutral compound, right? And the the attacking reagent is either a positive ion or a negative ion, right? So it has polarity, positive or negative, right? So this substrate, right, which is an organic molecule, right, which is electrically neutral, right, would be attacked only if it has positive and negative charges, because your reagent is positive or negative. So positive or negative will attack its opposite, positive or negative, right? So basically here we would be explaining how this positive and negative sites occur in an organic molecule, right, so that it can proceed for further reaction, right? And before this, we gone through inductive effect, where we have seen how displacement of sigma electrons took place, right? How displacement of electrons took place towards more electronegative atom, right, in the organic molecule. Here we would be dealing with, in electromeric effect, we would be looking those compounds that are unsaturated, or compounds that have multiple bonds. Either it has a double bond, or it has a triple bond, right? And this effect, electromeric effect, is due to pi electrons, right? Because we know that a double bond means a sigma and a pi bond, and this electromeric effect is due to the pi bond, which is formed by the sidewise overlap of orbitals, right, if you look at its chemical bonding. So if suppose this is an unsaturated compound, right, it has a sigma bond, it has a pi bond, right? Now in the presence of an attacking reagent, right, this effect occurs only in the presence of an attacking reagent. In the presence of an attacking reagent, the electrons of the pi bond, right, would be transferred to one of the bonded atoms, right, mainly to the more electronegative atom, or let's say to one of the bonded atoms, right? So here this pi bond, right, that consists of a pair of electrons, right? We know that a bond consists of a pair of electrons, right? So the pair of electrons of this pi bond would be transferred to one of the bonded atoms in the presence of an reagent, in the presence of a reagent, right? That's important to understand. So here this electrons of the pi bond would be transferred to oxygen atom, right, in the presence of a reagent. Say we add hydrogen cyanide to it, right, that will provide cyanide ions. So in the presence of cyanide ions, the electrons of the pi bond would be transferred to one of the bonded atoms, right? So the atom, right, that has acquired the electrons will become negative, right, because we know that electrons are negatively charged, so it will acquire negative charge, right? And this transfer of electrons is complete, right? Electrons would be completely transferred, right, to one of the shared atoms in the presence of an attacking reagent, right? So I'll just mention it over here. In the presence of an attacking reagent, for example, here we have taken cyanide ion, pi electrons would be transferred to one of the bonded atoms, thereby developing negative and positive charges, right? Because if it has negative and positive charges, then only it would be attacked by this reagent, right? So that's what our aim is, to understand how an organic molecule gets activated in the presence of an organic reagent. Because if you think that this is, or say this is a neutral compound, but why it reacts in the presence of an attacking reagent? Because neutral molecules do not react, they need to have polarities in order to react. So from where these polarities came? From this attacking reagent. This attacking reagent caused the pi electrons, right, to move one of the bonded atoms, right? And this movement, or movement of electrons, or displacement of electrons, is shown by a curved arrow like this, right? Curved arrow pointing towards the atom that has acquired this pair of electron, this pair of pi electrons, right? So this will become negative, this will become positive, this will become negative, this will become positive. Now, the other thing to understand is the attacking reagent, since now it has negative and positive charges, the attacking reagent may get attached, right? Now there is no more this pi bond, because pi electron is transferred to one of the atoms, one of the bonded atoms. So there is no more a pi bond. So in the second step, right, in the second step I have not shown the pi bond, the other bond, right? Here you have two bonds, here I have mentioned one bond, right? But I have charges, I have a negative charge on one of the atoms that has received the pi electrons, right? So since there are no electrons, no electron means no bond. Actually the bond has been ruptured in the presence of an attacking reagent, or the broken. Now we have only one bond, and we have charges, right, within an organic molecule. Now the attacking reagent may get attached to this, or it may get attached to this, right, depending on its polarity, right? So if it gets attached to the atom that has received the electrons, we call it a plus E effect. And if it gets attached to the atom that has not received the pi electrons, it's a minus I effect, right? For example, if you look at this, right, so when this electron movement is complete, this is how it will look like. This would be negative, say this would be positive, right? Now suppose I add a reagent, a hydrogen ion, this is a reagent, and it gets attached to this carbon atom, right, that has received the pi electrons. You can see this arrow, the electrons of the pi bond is received by this carbon atom, thereby making it a negatively charged atom. Now this reagent will attack this carbon atom, right? So when reagent attacks the atom that has received the pi electrons, it's a plus E effect, right? To electromeric effect we also call it as E effect, right? So it's a plus E effect if the reagent gets attached to the atom that has received the pi electrons. On the other hand, if we take example of this, if I reacted with the reagent cyanide ion, right, in the presence of cyanide ion, the electrons will move to the pi electrons of this carbonyl group will move to the oxygen atom, giving it a negative charge, and this has acquired a positive charge. Now if the attacking reagent will get attached to the atom, right, that has a positive charge, or the atom that has not received the pi electrons, because here pi electrons is received by oxygen atom, so it will acquire, this is your minus I effect, right? This is how it looks like, and this is your minus E effect, right? And the other important thing, now it's clear what is electromeric effect and the type of electromeric effect. And remember, this is a temporary effect. This is not a permanent effect like inductive effect, right? So this is in the presence of reagent, right? Now if I remove the reagent, this will move back to this stage, right? So this is a temporary effect that will take place only in the presence of the reagent, right? So it's a temporary effect occurs only in the presence of an attacking reagent. Right? This point is important with respect to electromeric effect. And there may be cases where you will see electromeric effect and inductive effect taking place together, right? So in such cases, only electromeric effect usually dominates the inductive effect, right? So if I have an organic compound where you have a group, right, where you have a say methyl group that is pushing its electrons, right, or say I have a chlorine group, right, I have a chloro group or any halogen group that can attract the shared pair of electrons of the sigma bond, right, thereby acquiring a slight negative charge, right, because we know that in inductive effect complete transfer of electron does not take place like it's happening here. The only the electron cloud is shifted towards the more electronegative atom, right? So if you have inductive effect and electromeric effect, which means transfer of electrons, it's transfer of electrons that will dominate, right? So if we have I effect, I and E effect together, it's E effect that will dominate. Right? And here it's a temporary effect which take place only in the presence of your attacking reagent, whereas if we talk about inductive effect that we have studied before, inductive effect is a permanent effect. It's a permanent displacement of electron clouds towards the more electronegative atom, whereas in this case, which involves the transfer of pi electrons to one of the atoms, and this transfer of pi electrons has taken place in the presence of an attacking reagent. Once this attacking reagent is removed, the electron will come back to the atom, original atom, right? So this is a temporary effect, whereas inductive effect was permanent, right? I hope this is clear. Right, now the other important points for this is this electromeric effect. We have discussed this. It involves pi electrons, whereas inductive effect involves your sigma electrons, right? And the inductive effect will result in the formation of slight polarities, right? Small negative and positive charges, whereas electromeric effect will result in the formation of ions, right? So here E effect, then you here have I effect, here ions are formed due to complete transfer of electrons. Here no ions are formed. Why no ions are formed? Because it's a distortion, or it's a displacement of pi electron cloud towards more electronegative atom, right? Because the electronegativity of the bonded atom is high, so it will displace electron towards itself, right? And the other is, this is a temporary effect, right, whereas this is a permanent effect, right? And the other could be in inductive effect. In inductive effect, it's only the presence of a group, right? For example, if say this is your chlorine group, this is a chlorohalogen group attached, right? This is methyl chloride, so it will displace the electron towards itself because of high electronegativity, right? There is no reagent involved here, whereas this has taken place only in the presence of reagent. For example, only in the presence of hydrogen cyanide that has supplied cyanide ions, this pi electrons will move towards the other atom, one of the atoms, right? So this effect take place. This requires reagent, whereas this does not, no reagent is required in inductive effect, right? I hope this is clear. Thanks.